করতে হবে because two students are absent. So when you think or identify a compound to be ionic, then instantly you should think there are ions, and there are many ions, and ions are regularly arranged. Okay, if you can remember this, whenever you see a formula of an ionic compound, if you remember this, then these things are all easy. Okay, just decide, yes, whenever I will see ionic compound, formula of ionic compound, I will think this, recall this. Then you can explain the properties of ionic compound. Then easily you can explain the properties of ionic compound. This is our topic today, properties of ionic compounds. I write here. Properties of ionic compounds. So this is the topic today here. Understand? Properties of ionic compounds. And there are many properties, and we'll study just two today, two properties today. One is electrical conductivity. This is here, the first property we are going to study. This is electrical conductivity. Okay, you know, I may have this pen, plastic pen, and a piece of metal I showed. Metal, key, plastic pen. So one of them is very safe. Which one? This. To work with electric cable. This one, right? If you touch this, if you touch the electric cable with this pen, then there is no risk. So this is safe. And if you use this metal, piece of metal to touch electric cable, then this is risky. Okay, what's that? What do we say? How do you explain this difference? We say this is good conductor of electricity. No, yes. This is not non-conductor of electricity. And this is metal, good conductor of electricity. Okay, that's good. And then the next question should appear in your mind when you get two substances, both are solid, you see here. One is good conductor, another is not good conductor. You should have question in your mind, which thing is there in the material that is good conductor, and which thing is not there in other substance which is not good conductor of electricity. Okay, this should be your question. Whenever you get one is good conductor, another is not good conductor, then this, if you are mentally healthy and you are a smart learner, then this should be your question in your mind. Then what is responsible there for this? Okay, so we got two things responsible for electrical conductivity. Two things. One is there, you know, what is that? What is that? Electrons. No, not only electrons. What is that? Free electrons. Okay, one thing, if any material has free electrons, then that's good conductor of electricity. If any material. Plastic pen or anything you say, all made of electrons, not free electrons. You cannot think anything. You cannot think of anything without electrons. That may be the particles involved in an object here. Maybe atoms, maybe molecules, maybe ions. These are three types of particles, you know. But whichever is there must be made of electrons. Nothing could have been possible without electrons. But are all the substances good conductor of electricity? Though they have electrons? So what is there? What do you need to be good conductor of electricity? Not electron. What's there? Free electron. And what does the free mean here? Does it mean you don't need to buy them? If buy one, get free? No. The free means free to move. Here, free means what? Free to move. That we can write here. Free means what? Free to move. Free to move. Okay? Free means free to move. Certain materials have free electrons. One is metal, any metals. There are many metals. The most common is copper. We use electric cable, basically made of copper, right? Everyone know. We see the plastic cover on the metal, but inside there, copper metal. Okay, that's good conductor of electricity. And you may have seen the overhead cable, one pole to another pole, the big cables. They're basically made of aluminum metal. Aluminum. So not only aluminum and zinc, any metals have free electrons. Free electrons means electrons there which can move freely. Move freely means the electron can move from one place to another place in the piece of metal, in that piece of metal. Suppose if this is a piece of metal, electrons are here, they can move to this place, from this place to this place. Again, they are free to move. Okay? And you know, electrons are very tiny, right? You know, electrons are like airy, like energy. Electrons have properties like energy. So they don't need space to move through. Electrons don't need any space to move through. Understand what I say? I mean, if you want to get out of the wall, suppose this is a wall, can you go away out of the wall without breaking the wall or without opening the door? Not possible, because you need space to move. Okay? But the particles, subatomic particles like electrons, they're so tiny that they can pass through your body. They can pass through a solid object, even solid. Understand? So where do you get free electrons? Metals. Okay? Metals. Then another thing we know, graphite. Graphite doesn't have a meaning. Graphite is a material. This you get in the pencil. This is the graphite material. And this is the inside solid of the pencil. Yes, this is made of graphite. And you know, pencil battery, there is also a lead. There's also lead inside the pencil battery. That's also made of graphite. Graphite is a available thing. If you burn wood, you will get the graphite. This impure form of graphite. Okay? Graphite actually a form of carbon. Graphite is a form of carbon. Carbon is an element. It has different forms. Carbon has different forms. Graphite, diamond, fullerene, nanotubes, some other forms. You will learn them later. Don't ask me now. She's very inquisitive. She asks questions of everything. But we'll study them. I will show you them later. I just know metals and graphite. These two materials, these two types of materials have free electrons. The electrons can move through the body through the solid state, even through the solid. If they're liquid, if you melt them to liquid, the electrons will also be there free to move. And if they're solid, they can move still inside the solid freely. Okay? So these materials are good conductor. Why? What do they have that they are good conductor of electricity? Free electrons. Okay. So now get another thing. Number two. Some other materials are still good conductor of electricity, though they don't have free electrons. Without having free electrons, some other materials are still good conductor of electricity. And What do they have? Other than free electrons, there another substance. Another substance. This is here ions. Where do you get ions? Where do you expect to get ions? What do you think ions are available? Ions are available in any ionic compound. Yes, ions are available in any ionic compounds. And you can identify a compound to be ionic. That we learn. It must be there. You shouldn't forget this. Must be there, I say again. So in any ionic compounds, ions are there. But ions are not enough to be good conductor. They should be mobile, I said. Mobile ions, I write here, mobile ions. Free electrons and mobile ions. Okay? And where to get mobile ions? Where to get? I told already where to get free electrons. We get two types of materials. And now ask you where to get mobile ions. Where to get ions? In any ionic compound. And where to get mobile ions? Look, any ionic compound. If you have an ionic compound, suppose sodium chloride, the salt, table salt we eat every day, there are ions, right? Ions are there in solid sodium chloride. But as that solid, the ions there cannot move. Okay, cannot move about. I say cannot. They can vibrate, but they cannot move about from one place to other place. Understand? Because you will learn the differences between liquid and solid. Liquid particles can move about freely, but the solid particles just vibrate. Okay, but mobile means they're moving from one place to another place. Is that possible in solid state? But this is possible for electron. Electron can move freely even in the solid. Understand? Later in another topic we'll learn this. But just now, ions are bigger. Ions are much bigger than electrons. Electrons are very tiny, like airy, like energy. So they can move freely through solid object. But if this is mobile ions, the ions there little bigger. Okay, so bigger particles cannot move through other particles in solid state. Okay, so you are clear about the availability of ions. Any compounds have ions, right? And you need to make them mobile. If you want them to conduct electricity, then they should be what? They should be mobile. Okay, so here we have two ways. We have two ways to make the solid ionic compound, ions there, mobile. You can guess which are the ways to make solid particles to be mobile? She says heating and dissolving. Heating is to be changed little. Anybody? The word she says suggests that heating is not enough. How to make the ions mobile? Molten, yes. So two ways we can get this. Ionic compound, if you melt ionic compound, not heating, it's molten. I mean melting. Okay? Molten ionic compounds. No. Ions will melt if we heat up to certain temperature. Not heating enough to melt an ionic compound. Okay. So this is better you say not heating. Heating could be you are heating by 10 degrees. That's also heating. So do you expect that ionic compound will melt if you heat by 10 degrees but warming? No. That's why you are wrong. You should say melting. And after melting, you will get molten ionic compounds. Are we clear? After melting, we'll get molten ionic compound. Are we clear now? So this is a way to get mobile ions. But must be ionic compounds. Other than ionic compounds, you won't have ions too. Okay? Another way, we have another way to get mobile ions. What's the other way? Or the other way? Dissolving, yes. Dissolving in water, not liquid. Here is still wrong. Dissolving in water. Okay, if you try to dissolve this in other way, that won't dissolve actually. It dissolves basically in water. Everybody clear? Because when solid melts, then that becomes liquid, and the liquid particles can move about freely. You know this? Liquid particles, like the water, liquid, and molecules in water can move freely. And if this is dissolving water, this is almost same thing. When particles dissolve in water, ionic compound dissolve in water, they will split, the ions split, and can move, swim in the water molecule, in the water. So they're still free. Okay. So are you clear about these two types of substances you expect to have? Free electrons and mobile ions for good conductivity of electricity. I started with these two substances. I told you. Suppose one of them is good conductor, another is poor conductor. There are many examples. And whenever you get a substance good conductor of electricity, you must think this substance either has free electrons or mobile ions. And to be sure whether that consists of free electrons or mobile ions, you need to see the state. If the state is solid, the substance conducting electricity in solid state, then that's certainly by free electrons. Okay, but if the substance needs to be melted to be a good conductor of electricity, that's of course by mobile ion. Are you clear? Do you have any question regarding this? Yes. What? I say ionic compounds. Ionic plastic, not ionic compounds. Okay. Anything could be molten. Anything molten means liquid. Some liquids are already available in nature. Suppose water here, petrol, kerosene, diesel, edible oils. They're all liquid. Okay, but they are not good conductor of electricity. What's that? Molten is a condition, but that should be ionic, another condition. When ionic compound is molten, then that would be good conductor of electricity. Why are you again repeat? Okay, are you okay? Are you okay? Are you okay? Do you have any more questions? Any more questions? You should have a question. If I get question, I'd be happy. I like to have question. This may no question. So here I have a question, and for electrons I say free, and for ions I say mobile. Don't you have any question, any query about this difference? How I use these different words? For electron I use free, and for ions I use mobile. Actually they are meaning the same, very similar meaning. Free electrons means free to move, and mobile ions means they also can move. They can also move. There's little difference between them. They are very synonymous. Okay, we're using this in the same sense. Little difference. Free means actually the extent is greater. Like the birds. Birds can move freely, and we people also can move about, right? We people also can move about, but not like the birds. The birds have greater opportunity, greater freedom of movement, right? They can move at any direction. They can fly. We cannot do that, right? Free electrons are free. This has greater dimension of movement. They don't have time to move. They can move very quickly. This is one. Another is they can move through liquid and solid. So this is the freedom. But to be ionic compound, they just move when this is liquid only. Liquid by molten or what? Aqueous. This is what we call. When we dissolve something in water, the solution we call aqueous. The solution we call aqueous. Aqua means water, and aqueous means watery. Whenever we say aqueous, it will mean watery. Understand? No, not melts, it dissolves. It's called dissolving. Dissolving means melting is different. Melting is different, dissolving is different. Melting is you will have to break or weaken the intermolecular force, or here's not electrostatic attraction, by heating, by kinetic energy, by force, that particles will get away from each other. And for dissolving means when you're adding water, the compound splits. It's due to the action of the water molecules. Water molecules pull the ions away from each other. Water molecules there, when you're adding them to water molecules, the water molecules pulling the ions away from each other, breaking the lattice. Yes, breaking small pieces. That's split. That called splits. Yes, ions can move. Okay, we're finished, right? We're finished. So we move to the next topic. We have an experiment now. Next topic means the same topic. This is now an experiment to prove that this really happens. So what we say, this really happens when I prove that with an experiment. So see here an electric cable. Electric cable, we make electric circuit. When I make electric circuit, you know what is electric circuit called? Did you see electric circuit? Anybody? What is the circuit to have? What should the circuit have? Okay, this is here a bulb and cell, a battery, and here you get switch. The switch is open, right? The switch is open, and the battery is okay. The light is also okay, but the light doesn't bulb. The bulb doesn't light. The bulb doesn't light. This is the reason why. Why it is? Because switch is off, right? Switch is off. Now get a metal piece. This is a small spool. This is a metal piece, suppose iron piece, and we know this is good conductor of electricity. Even this is solid, good conductor of electricity. So what is here to conduct electricity? Free electrons. So let's check. Should this conduct electricity? Yes. Let's check. So place this here. I mean, you try to connect them, connect the switch, complete the circuit with a metal piece. Whenever you do, you will get the bulb will light. Okay? Okay? Just place this here, bulb will light. What does it mean? This is good conductor of electricity because it's connecting, completing the circuit. Okay? So this could be an experiment that this is a good conductor of electricity. So we had another thing, was that ionic compound, right? Ionic compound. And in two ways we can do the experiment. First, get a container, some ionic compound, maybe sodium chloride. Look, maybe sodium chloride. So solid sodium chloride here, okay? And we place this here. The sodium chloride, solid sodium chloride, solid sodium chloride here. And you know, solid sodium chloride consists of ions, right? Consists of ions. Do you expect the bulb to light? Do you expect the bulb to light? Why no? Yes, ions here in solid. Previously, I was using metal piece. In metal piece, you got the electrons which can move freely even in the solid state. Liquid is also okay, solid state. But here we are using solid ionic compound. Solid ions are there which are not mobile. So that won't connect the circuit and one complete the circuit, one light. Yes, I'll give you. So now you got this sodium chloride here, the ionic compound here, not connecting the circuit because this is not good conductor of electricity. So we can do one thing. Here, add some water. Just add some water in the container containing salt. And whenever we add, you will find the bulb will light. Understand? Whenever you do this, you will find the bulb will light. So how this happens? How this happens? Because here is aqueous ionic compound. So here are mobile ions, right? Here are What are there? Mobile ions. When you get the mobile ions, they are good conductor of electricity. They're connecting the circuit and will the bulb will light. Everybody clear? So here we have the other way to make ionic compounds mobile. What's the other way? We got molten. So for this, don't take sodium chloride because the melting point of sodium chloride is very high. It's 800 plus temperature. So you cannot heat to melt sodium chloride in chemistry lab because 801 is a huge temperature. So better you get some compound. It's also ionic compound, lead bromide. Lead bromide is a compound with relatively low boiling point, low melting point. If you heat this, it will melt. So this is a lead bromide. Everybody clear? Solid. And if you try to connect the circuit with a solid lead bromide, will the bulb light? No, because it is solid. So now we heat. Now you heat to melt. Not only heating, it must mention. If you want to melt this, you say heat to melt. Okay, melting is important, not only heating alone. So if you heat to melt, whenever it turns liquid, the bulb will light. Everybody clear? So these are proofs, these are evidence that they do. Okay, if this is a question, describe an experiment to prove that solid lead bromide does not conduct electricity. Can you prove the experiment? Describe the experiment. Solid lead bromide does not. Okay, so just you will draw this. You may describe this. Excuse me. You may answer this question in two ways. One, you just draw this. Here, leveling must be leveling light, cell, and solid lead bromide, and you will write there the bulb will not light. Despite of the setup, the bulb will not light up. So this is enough. Not good conductor. Okay. So now, or you can describe this question. Describe the experiment. You will say a circuit with bulb, cell, okay, cell, set this, and the switch or the open end, two open end dip in lead bromide. I say again, I repeat, two open ends of a circuit, two open ends of a circuit containing a bulb and a cell dip in the lead bromide, solid lead bromide. The bulb won't rise. Finished. So this is not good conductor. If the question is a little different, can you describe the experiment to prove that molten lead bromide is good conductor of electricity? Molten lead bromide is good conductor of electricity. Can you describe the experiment for this? So what to do there? Say or draw two open ends of an electric circuit containing bulb and cell dip in the molten lead bromide. Dip in the two ends. We dip in the two ends only, not the circuit we dip in there. Two ends. The bulb will light. Finished. So can you describe the experiment to prove that aqueous sodium chloride is good conductor of electricity? Aqueous sodium chloride is good conductor of electricity. Anybody? Okay, thank you. Now see here, I show properties of ionic compound. The first thing is conductivity of electricity that I was telling. Electricity is conducted by either respond to me, either free electrons or mobile ions. Remember, free and mobile, these two words are emphatic. Don't say electrons, don't say ions only. Understand? So now, free electrons are available in and graphite, yes, and few other allotropes of carbon. Allotropes you will learn later. So now, come on. Mobile ions are available in molten or aqueous what? Aqueous? Yes, that must be there. That must be there. Ionic compounds. Okay. Sodium chloride or any other ionic compounds. Yeah, we say sodium chloride is a model, an example. or any ionic compounds in ionic crystalline solid. So there's no free electrons, no mobile ions, right? No free electrons there, no mobile ions there, right? Okay, because of they're closely packed. They cannot move about, okay, cannot conduct electricity. When it's dissolved in water, when the compound is dissolved in water or melted, what would happen? The ions become mobile and will conduct electricity. Look, you must get a question in your O-level exam on this, electrical conductivity, simply for 1 mark. Okay, now